Hello everyone, my name is Minyu Liu. Today I'll be presenting our work on unsupervised network pretraining via encoding human design. This is a joint work with Arun Maya, Ansel Tusal, and Si Chen. So unsupervised pretraining is a learning techniques for training deep neural network. It's a two-stage process. The first stage is about pre-training a neural network for unsupervised learning task, and then fine-tune the neural network for the supervised learning task. So it is based on the idea of shared representation. The representation learned during unsupervised learning stage can be used for the supervised learning task. This is the technique lead to the renaissance of deep learning in 2006. We don't know precisely why pre-training work, but it's hypothesized that pre-training initializes the neural network in a way such that fine-tuning can drive the neural network to a region that would be otherwise inaccessible. So here is an example. Each point in the graph is a neural network, a particular input-output mapping. All the neural networks are initialized in the center, but those with the pre-trained initialized with the pre-trained weights converge to the right, and those randomly initialized converge to the left. And the one with the pre-trained weight has a smaller variance compared to the one that is randomly initialized. So the existing pre-training methods are mostly based on signal reconstruction. So basically, you train a deep network that try to reproduce the signal itself through some information bottleneck by minimizing the Euclidean loss. Examples in this category including the stack RBN, denoising autoencoder, or sparse autoencoder. But a fundamental question we have is that is minimizing reconstruction error the right way for modeling the images? We know that here is an example. You have a reference image here. By translate the image several pixels to the left, and you gradually increase the reconstruction error. But the reconstruction error is much larger compared to an image that's without the human inside. So clearly, the reconstruction error is not the right way to model the image. So learning to reconstruct the signal may not be the right thing to do. So in this paper, we propose pre-training based on encoding human design. So we pre-train a neural network to learn to generate a feature vector similar to the hand design feature vector. And then we fine-tune with class labels to maximize the recognition performance. And this way, we can leverage existing computer vision research results, and we can inherit the invariance property that is in hand design feature. So here's one example of replicating the Hawk feature. Hawk was a popular feature before the deep learning era. We use a three-layer convolutional neural network to replicate the Hawk feature. With an input image, we try to produce a feature vector similar to the one that's extracted from the Hawk feature extractor. So replicating the Hawk feature, we can capture the object shape formation and be invariant to the illumination change. And the bottom is the figure of the learned filters. We found that those filters resemble edge detector of different orientations. So here's some experiment results on comparing different pre-training methods. Most of the hand design features were developed for human detection, so we use the in-real human detection datasets for comparing the pre-training method. So the light purple one is with reconstruction, minimizing the reconstruction error by autoencoder. The green one is by random initialization. The black one is by sparse autoencoder pre-training, and the red one is by our method that is replicating the Hawk feature. We found that replicating Hawk feature leads to a network that is perform better than other pre-training methods. when you apply a SVN classifier and a bounding box regression step after the extracted feature, you can further improve the performance to 13% miss rate. So to conclude, we show that hand design features are useful, and in future we plan to replicate other forms of human intelligence, and more discussion and result can be seen in the poster session. Thank you.